Okay, now in this lesson we're going to learn how to actually apply these matrices to system problems like what we were doing before. Now technically you could solve this problem by elimination if you wanted to, but we're learning how to apply these matrices, so we're going to use Cramer's rule. Now what Cramer's rule is you get three matrices. You get D, dx, and dy. Okay, so these three matrices use these numbers right here as their matrix. Okay, so now the regular D, just the regular matrix for this problem, is sorry, not using a bracket, it's a determinant, so we're using the straight ones. So we want to use 5, 7, 6, 8. Okay, now notice that's just these numbers right here. So that's not using the solution. The regular D is without the solution and just using the coefficients in front of the variables. Okay, so now we want to do dx. Dx basically replaces the x column with solutions. So it's the same matrix, the 7 and 8 don't change, but you put the solutions now in place of the x, so negative 1 and 1. And finally, your dy is the same original matrix, but instead of the y column, you put the answers there. So 5, 6, and then you put the answers negative 1 and 1. So this is how we work Cramer's rule. And why this is useful is because we figured out that x is, if we actually want the answer for x, all we have to do is take our original determinant and divide it into our dx determinant. So take our dx and be divided by the d. And to find y, you take the dy and divide it by d. Now, what we're saying in these d's is find the actual determinant. So what that means is each one of these actually has an answer. So I need to multiply my 5 times my 8, and so take my 40 and subtract it by 6 times 7. And so my d is equal to negative 2. Okay? And then we should find our dx, so that's going to give me negative 8 minus 7. So negative 8 minus 7, that's going to give me negative 15. So this is my dx. And then finally my dy is 5 minus negative 6. So that's going to give me 11. Okay? So my d, now I have all of these numbers. I take them over here to the left and plug them in. dx is negative 15. I divide it by negative 2, and that gives me the actual value for x, which is just 15 halves. I should just change it positive. So 15 halves, or 15 over 2, is the answer that would make this true here for x. Okay? And then to find y, all you do is you take your dy, which is 11, let me use a different color, 11, and divide it by your d, negative 2. So this is the answer for y in this solution. So in other words, the actual solution set is 15 over 2, comma, 11 over 2, negative. Okay, so that, if I was to actually graph these two lines, they would cross at 15 halves, comma, negative 11 over 2. Okay, and you can actually turn those to decimals and see what that would look like on a grid. But this is Cramer's rule, and it's just finding these three matrices. And again, how I came up with this is the coefficients on the variable portion, and then for the dx you replace the x with the solutions, and for the dy you just replace the y coefficients with the solutions. Okay? And then you find the determinant of each one, and then do this division. This is the actual rule over here on the left hand side. That's your real rule for what to actually do for Cramer's rule. Okay. If all else fails, solve by elimination, and you'll get the right answer.